Hello, good afternoon to all of you. The catalysis process mainly classified into two classes is a homogeneous catalysis and heterogeneous catalysis. In heterogeneous catalysis, 19% of the examples are comes. Homogeneous catalysis is the catalyst and the reactant are in the same phase, usually liquid. And the heterogeneous catalysis, catalyst and reactants are in different phase. Generally, the solid material catalysts are used or come under the heterogeneous catalysis, where the reactions takes place at the surface of that solid material. That solid materials act as the catalyst. Example: nickel catalyst, platinum catalyst, palladium catalyst are comes under the category of the heterogeneous catalysis. We can understand the homogeneous catalysis by studying these examples. Here are the examples. XYZ is the example in which the reactants molecules and in between that is the catalyst is also there. Means the reactants and the catalyst are in the same phase. They form the intermediates and then convert into product and then separate out the catalyst. It is a heterogeneous homogeneous catalysis. But in the case of the heterogeneous catalysis, the reactants are adsorbed on the surface of that particular catalyst. Means reactions takes place on the surface of the catalyst, that is catalyst surface, and then form the intermediate, and the products adsorb on the product is adsorbed on the catalyst surface and then converted into the products. Mean in these reactions the phase of the catalyst is different and the phase of the reactant means substrate is different. So in the notes we have the two types mainly, that is the homogeneous catalysis and the heterogeneous catalysis. Homogeneous catalysis, catalyst is present in the same phase as that of the reactant and the product. Means the catalyst, reactant and product are in the same phase. Just example is the reaction of nitric oxide gas catalyzes the combination of the sulfur dioxide and oxygen in the lead chamber process for manufacturing of the sulfuric acid. So in this, nitric oxide is act as a catalyst which remains as it is in the products, but they are in the same phase as that of the sulfur dioxide and the oxygen, that is gaseous phase. The theory of the homogeneous catalysis. According to theory of the homogeneous catalysis, function of the catalyst is to bring down the activation energy and provide an alternative path. The catalyst first form intermediate complex with the reactant. Here the example is given here, that is A plus X gives the AX as the intermediate, where A is the substrate and X is the catalyst. So X is the intermediate complex and K1, K2 are the velocity constant for the forward and the backward directions. The intermediate complex to react with the other reactant molecules, that is AX is the intermediate, react with the B other molecules form the AB and X remains as it is, that is the catalyst that is remain as it is, that's in the form of X. Thus the rate of the reaction we will give the X K3 is equal to into concentration of AX plus concentration of the B. This theory of the satisfactorily explain the mechanisms of the homogeneous catalysis. Next is the heterogeneous catalysis, in which the catalyst is present in the different phase than that of the reactant and the products. So most of the cases catalyst is solid while the reactant and the products are liquid or gases. Catalysts are usually metal or an oxide is present finally divided state so as to provide a large surface area. Example is the oxides of sulfur dioxide, SO2, plus 2SO2 is presence of the platinized asbestos is the SO2 gas and O2 gas. Platinum as a catalyst in the form of solid give the SO3 as a product in the form of gaseous, and platinum is remains means it is in the form of solid state, so it is a heterogeneous catalysis. Next example, decomposition of S2O2 in aqueous solution in the catalyst used by colloidal platinum. His example is the platinum and S2O2. Two molecules are used to convert into the water molecule and oxygen gas and platinum as a catalyst. So the theory of heterogeneous catalysis. The theory is generally based on the phenomena of the adsorptions. So adsorption theory are known as contact catalyzed theory. The action of the heterogeneous catalysis is due to the presence of the free valencies on its surface. These free valencies offer an opportunity to reactant molecule to undergo chemical reaction on the surface of the catalyst. Atom within the body of the catalyst is joined to the surrounding atoms, and hence all these valencies are satisfied. Nickel is a catalyst is there. Nickel is the best catalyst used for these reactions.